Welcome to another episode of whatever this is of game engine development. This week, I'll probably go over some math and some unit testing. I woke up feeling so tired today, and then for the first time in a few days, I tried making coffee, and I ended up having to throw 5 cups of coffee away because it tasted like, I don't know, washing. It tasted like a washing machine. Yeah, that's right. So recently I started creating my own math library for my game engine. And the first thing here that you might be asking is, why are you creating your own math library instead of using something like GLM? And the answer for that is because I want to. It doesn't get much deeper than that. But also because it is a good learning experience, and I wanted an excuse to buy this book. Isn't this the greatest book cover of all time? Look at it. Look at this. And another reason that I think is a good reason, but I'm not sure because I just started this game engine, is that I don't think I'll need all the things that a library like GLM has. So it's a matter of cutting on how much code the engine has. Okay, so let me show you what I have here. So I have the vector3 class here, just some constructors and some basic functions that I got reading the book. And then very similar to the matrix, just constructor, this function that I'll need when using OpenGL, which I need to cast like the matrix for a const float, and then overriding operators, plus, minus, multiplying matrices, which is not fun. I did this by hand. And on the CPP file, I have the identity matrix. The identity matrix is something that is very useful. I'll be using a lot on the renderers. And then when doing these things, you might ask yourself, like, how are you sure that the vector class works? How are you sure that the matrix class work? How are you sure that the multiplication of matrices are happening correctly? Because you should ensure that these things are correct, right? And there's no way to do it. I'm kidding. One way to do it is by using unit tests. And this is not something that is talked about a lot in game development, I feel like. And I understand that you cannot use it in every situation. Like, how do you test a renderer? It's complicated, right? And will demand a lot of resources. But for something like a math library, it's very easy and simple to do. So for example, here I have this test file, and for example, I have the test for the constructors. So I just create an empty vector, and I'm checking if the vector is created correctly with the values that I specified. And the same for creating with 3 values. I have to create the vector with those 3 values, and the vector has to have those 3 values, right? So I'm checking this here. And you do this for everything that your vector is going to do. Plus operator, minus operator, dot product, cross product. And I guess that the best way to do this would be to actually look at a math book and get the examples and code them as tests. Or maybe you can just make up some vectors, some values, and you go into the internet and get a calculator that you trust in, you solve there, and then you code that as tests. It's really not as complicated. So for a demonstration, I'll try to do some live coding, and I'll be creating a vector2 class here. So I have my vector2 class here. As you can see, it's empty. And I have my tests, which is empty constructor, single parameter, 2 parameter, and copy constructor. So how am I going to do this? I have to come here and actually start creating the vector2 class, right? So I create X and Y, and then I have to create all those constructors as I have here. And I could just come here and just put all zeros here. Now, since I put all zeros there, it's obviously wrong. So let's see what I get here. As you can see here, it failed. It shows you where it fails. So it required that v.x was 2, but as you can see here, it was 0. So it failed because we tried to check if 0 was equals to 2. If you know something about math, 0 is not equal to 2. So what we have to do is that we have to go back here and actually fix this. So now if you try running it again, it should run correctly. And as you can see here, I'll test fast. That's what we want to see. So what I'm doing here is called test-driven development. It's a good way to ensure that what you're doing is actually correct. But I'm not done yet. I still have to go through, I still have to create normalization, magnitude of a vector, and overload all operators. So I'll write those tests right now. Now, if you pay attention, most of these tests are really very simple. They just do the bare minimum, if you ask me. So there's a lot of work that can be done here, don't get me wrong. With time, I definitely want to expand this and also make continuous integration. So every time that I change something, it will run all the tests and then I'll know if something is broken or not. Now I have to go to the vector2 class and implement everything. So I'm gonna do this now. That's way too much work. Let me take a coffee break. At this point, I think I have everything, so let me test and see how it goes. As you can see, I made a mistake. That's why tests are useful. Line 88. Yeah, so the length here is going to be 0 because there's vector2's do not have z. Alright, so we got everything, that's good. So I believe that the vector2 class, it's working at least at a bare minimum for me to move on. So another thing that I implemented recently is time step, which is basically having the ways to measure how long a frame took and also waiting for some time if the frame took less time than we expected, so we can keep it locked 30 or 60 frames per second or more if you want. And this is a thing that actually has to be platform independent, and this is how I've done it. So I just have this file with two classes, right? getTicks and sleep. And so on the application, when I start my frame, I calculate that delta time, and let me show you how this looks like. Okay, so as you can see on the log here, we have our delta time. That's the behavior that we wanted. Here's how it works in the application. So I get the delta time by using the current ticks and the past frame ticks, and then I update the last frame ticks, and then I update everything that I had to update. After we did all the things that we wanted to do, we just calculate how many time we want to wait, and if we want to wait some time, we just tell the platform to sleep for that time. And frame target time are constants that I have defined it here. But if you look at how this is implemented, for SDL, it's just a function call. And I don't really like the way I've done this, to be honest. The way this is working right now, the file with the correct implementation is just have to be included on the project, which means that we have to know which platform we're going to use when we're generating the project, which I don't really like the idea much. Basically, there's no dynamic way to detect the platform and then we create an object with the whichever functions that we need. So something I'm considering is to change this to a more of a object-oriented approach. Let's see. This is probably something that I'll have to revisit in the future. Okay, so that's basically this that I had for the last 2 weeks of progress. It's not a lot, I'm doing this very slowly. I think I mentioned this on the previous video, because if I rush myself, I tend to create a lot of mistakes and I end up creating another engine. I want to create this, I want to really think about the things that are going into this engine and do this correctly this time. So that's why I'm going very slow. The next things that I'm going to work on should be getting Dear I'm Going up and running. So we have some sort of debug UI that we can actually do stuff with. And then after that, I think I'm ready to start creating the renderer, which should be exciting. So thank you for watching, and hopefully I'll see you on the next one.